All right, homework 11, problem 2. So, problem 2 asks us to prove this identity. And they give us some information. They tell us that x and y are jointly strict sense stationary. So what does that mean? That means the joint statistics of x and y are the same as the joint statistics of x of t plus some time shift epsilon and y of t plus the same time shift epsilon. So we can write that the expected value of x of t1, y of t2, by the way, keep in mind that these t's do not have to be the same t. However, these epsilons must be the same. So, expected value x of t1 times y of t2 gives us expected value of x of t1 plus some constant epsilon times y of t2 plus some constant epsilon. So this t1 and this t2 don't have to be the same, but these epsilon has to be the same. So the joint statistics of this is equal to the joint statistics of this. If a function, or stochastic process rather, is strict sense stationary, then it is also wide sense stationary. In that case, the autocorrelation of xy of tau is equal to the expected value of x of t plus tau times y of t, right? Because if it's strict sense stationary, then it's wide sense stationary, which means the autocorrelation depends only on the difference between these two. The difference between these two is tau. So, now, using the property that it's strict sense stationary, we can add an epsilon here and the same epsilon over here. Again, these times don't have to be the same. But now the epsilon that we have to add has to be the same. So what I'm going to do is I'm going to add a minus tau to this and this. So this is going to become expected value of x of t plus tau minus tau, y of t minus tau. So I'm adding a minus tau or subtracting tau. So what happens here? These taus cancel, and we're left with this. So we get expected value of x of t times y of t minus tau. I can rearrange these because it's a product inside, and you get expected value of y of t minus tau, x of t. But this is equal to the autocorrelation of yx of minus tau. I just switched the y and the x, but again, because it's strict sense stationary, it's also wide sense stationary, so it's only a function of the difference. So therefore we have shown that r of xy of tau is equal to r of yx of minus tau. And that completes the problem.